Ladies and gentlemen, please welcome Mr. Dr. Engineer Johan Blom. Thank you very much, Mr. Blom, to be here at the last minute. So we are really listening to what you can bring us as a message. You can do it in 20 minutes?
I try.
Okay. Okay. Thank you very much.
Okay, thank you for your kind introduction. Thank you, Rubcycle, for inviting me. And I will start with, okay, the title of my presentation. It's using retire tires in asphalt pavement. And I want to show you that it's like a new start, because in the United States they are already doing it. And I think that it's time also for us to do this. So the content of my presentation will be that I will give you a short introduction about asphalt, and I will tell you something about some trials they did in the previous years in Belgium, and then I will tell a little bit about the approach and the benefits we are thinking about in using rubber or recycled rubber in asphalt. So the idea is to use it in asphalt roads and make it beneficial. And at the end, I will start or finish with a conclusion, which could be the start of a bright future for rubber. As you can see on the slide, this is a specimen we got from a road, and you can see how asphalt is made. So asphalt is a combination of bitumen, which is the binder, and we have sand. So we make from the binder, we combine it with sand, we make a kind of mastic. So that's like a cement glue. And then we have different kinds of stones. So, and these stones are then mixed together with the binder, and so we can make like an asphalt pavement, which we can use for our roads. There are, of course, different combinations. We can play with the size of the stones. We can play with the bitumen. We can add all kinds of different materials like polymers, and maybe rubber, because it's also a polymer. We can also use fibers, so even the small pieces of steel or fibers which are in the tires, we can also use them to increase the performance of our roads. And yeah, so it's important that we develop systems and we tune these systems in order to make more intelligent designs, because I think everybody knows at this moment repairing roads, it's very costly, but it's also time consuming. All these road jams and all these queues, it's something we have to avoid. So, if we look to the figures, facts and figures, we can see that asphalt mixtures are used in large quantities. Most of our roads are asphalt roads. In 2015, it's a number from 2015, around 5 million tons of asphalt was used on the Belgian roads. And of course, these roads need to be repaired. We have to, and also there is still a need for new roads. Of course, if we want to, and one of the things we are doing now is, you see these green feet, so we are already thinking in the area of recycling, is we want to recycle, and one of the things we are doing is we are recycling the asphalt, because in most cases not the complete part of the asphalt is renewed. Only the top layer is scraped off. This reclaimed asphalt, these top layers, we can reuse them in our asphalt process. So what we do, you can see around 1.5 million tons of this reclaimed asphalt is already used. But there are some problems, because these reclaimed asphalts, they are, oxidated. They don't have the same properties and the same performance as new asphalt. So we need additives. And one of these additives are polymers. Of course, they are expensive. And we are thinking about using rubber as an additive. We saw in the United States, in America, that there are possibilities to use this rubber as a replacement for the polymers we are using now. And this could be very interesting. So, of course, if you are designing or want to develop a new product, you need standards. That's what the previous speaker also said. There is a need for standards, especially roads. Okay, private roads, but that's such a small part. But public roads are made, and they need to be standardized. There is a kind of agreement. There must be standards. Otherwise, you cannot produce that road. And that means that governments have to take their responsibility in allowing these new techniques into new pavement and new pavement techniques. And that's a little bit a problem. Here in Belgium, at the moment, RAP can only be used in the bottom layers. In the top layers, it's not allowed. So only in private projects, there you can use it. Of course, if you make something new, it must be also durable, even more durable than the material you started with. That's a little bit the aim. Otherwise, there is no benefit. And of course, what is also something important, that if you make something, you add something to a material, which is now at the moment recyclable, that in the next decennia, it could also be recycled again. Otherwise, you end up with something which is not recyclable anymore, and that's not what we want. You see, of course, roads in the past, they were used in some cases as a kind of garbage bag. We have a waste material, let's put it in the road. It's gone. And there are some examples of steel slags, fly ash, roofing, but also tar, asbestos, and all these things. You can put it in roads, but I don't think this is the way we have to go in the near or in the future. Okay, so there are some challenges. Definitely there are some challenges, and these are scientific challenges, but these are also challenges for the governments, for the people who, the entrepreneurs, the sector, the complete sector. So one of the things, the material itself. We need certificated material, constant flow of material. It must be always certificated. We need to have a kind of method that we can accept these materials in our mixtures. So they must be of a good quality. Another thing is that we have to describe standards. Standards, not only for Belgium, but maybe for Europe also. But if we want to use it in Belgium, there must be standards. And even here in Belgium, it's very strange, because we have standards in Flanders, we have standards in the Wallonian part, and even these standards diverge. So it's very difficult. And, okay, what I said is we have to be careful that roads don't become waste dumps, so that we don't end up with, okay, bring us everything, we can use it. No, there must be a gain, there must be a performance gain. Of course, if we develop something new, we need durability, and all the properties of a road must be okay. So, for instance, skid resistance, rutting, fatigue, water sensitivity, all these factors must be the same or even better than what we do at the moment with conventional bitumen roads. So that's also something important. And it's an important sentence, so you see, using new materials in asphalt takes a lot of time to convince and test. It's because you have to convince everybody, so you have to do it better, have to do it really perfect, otherwise it's doomed to fail. That's why I think there is an enormous potential and there is an enormous need also for academic research. And that's a little bit what the lack in the past was. Yeah, we can use it, we can gain money, but what is it doing in our roads? We don't know. It's cheaper, we can gain money. But is there an advantage? Sometimes it was a little bit, yeah, not very clear. So, this is the idea. You see a lot of cars, so a lot of roads, so it's interesting, but these cars have tires, end of life of these tires, so we want to mix them, not with a mixer of course, but we have to develop a system. And until now, there are some systems, but in Belgium it's not existing at the moment. So a mixing installation or a really good developed process to get it in. This is the big factory. That is the factory where they make the bitumen mixtures, and then they put them in lorries. They combine them there with stones, and so their cement is made, the bitumen and the sand is mixed to a cement. Then it's combined with stones. They bring it with big lorries to the paving site, and there it's put on the road. Okay, so we have a lot of steps, we have a lot of different things, and of course we have already machines for paving. So the idea is to make something at the plant and that we can still use the conventional paving machines and technologies on site. So that's a little bit the idea. It's not the idea to develop a complete new road. So, former use in Belgium. So I found some examples of experiments they did in the past. And one of the experiments, you see a race car. It's quite a dated race car, but it was the famous racetrack Francorchamps in Wallonie. And they tried to use their rubber grains in the asphalt. The problem was they always have a very narrow time slot, so they did it very fast. And there was a Belgian race, Formula 1 race, and immediately, a few weeks after the paving, they started this race. So they loaded the top surface too fast, and they had disastrous effects. So it's important if you develop something that you also do it with a well-overthinked method, and that don't do fast work, because it ends up with a disaster and then nobody wants to use it again. So good research, thinking about things and looking at all the facets is very important in the development of a new technique in a new application. The only other problem was that they only have one milling machine. So they wanted to do a lot of things in a short period, but they have only one milling machine, so there was a very big problem. So, until now, there is not everybody is really convinced of this. So we have to make a new start and convince the people that this technology could work and should work. So there are different factors. One is the plants, the people who make these asphalts, the mixtures. The other is the bitumen factories. We don't have anymore some bitumen factories in Belgium, but the people who make bitumens. And of course, there is a need for research. At this moment, not a lot of research is done on this topic at the universities. So I think there is a large gap to overcome and to really start academic research and find some solutions for these applications. Asphalt rubber. So in the USA, you see that they are using this rubber with enormous success. In new roads, they use up to 50% or even more of rubber in their new pavements. So it's really a success. It's really something which is... there are two types. There is a dry process, and mostly there are riddle rubber grains they are used, and this is in most cases used for damping effects, so to reduce the noise. And one of the parts, or one of the things we do in our research group is looking at silent roads, because I think roads, everybody knows the sound of roads, and it's important that we can reduce this sound. And there is also a wet production method where we grind the grains to a very small scale, and we combine them. We really going to blend them at a molecular level, so they are making. We are making a modified bitumen. So 50% of the total weight of the cement. Only wet process is micro, so there you can really change the properties. It means that you can replace these very expensive polymers which we are using now. So this could be a solution. Okay, of course, all these things must be stable, must have all the same properties, so it's a little bit complicated. And you see at this moment around 100,000 tons per year of this material is used, so it's a lot. Other use, so that's the SBS, that's the styrene, butadiene styrene. That's one of the products we use in the reclaimed asphalt in order to give it a new life. Because if you have old asphalt, this is all oxidized, so it means that it becomes brittle. And one thing we don't want is that bitumen becomes, or asphalt becomes brittle, because then it starts to crack. We have deformations which are not, which are staying there for a long time. Bitumen has one important thing, and that's the self-healing. So if you have bitumen with a certain elasticity, in cold periods it will get harder, but in warm periods of summer, it becomes a little bit more elastic, and it can heal itself. And that could be also interesting. By adding rubber, you can play with these viscosities, you can play with these properties, and you can improve the self-healing effect of this asphalt. So, noise reduction is one, and of course, replacing these very expensive polymers. This is a little bit the idea of, it's a little bit complicated, but this is a mechanical behavior. So here you have a spring and a dashboard system, so it's a viscoelastic behavior. So, and you can play by adding rubber, you can play on these spring effects, so you can make it more elastic. So it's an interesting thing. This is a little bit how it works. So we do a lot of tests, and you see here that we are looking at really small scale, and by changing some properties, we can play on the bindings and we can play on mobility of some particles. And this can be really, if you change things on nano or on micro scale, this can have an enormous effect on the real life scale. And that's important that we understand that. So that's a little bit the opposite from what we did in the 80s. Let's use it and see what is going to happen. Now we are looking at each particle, we go really into detail, and then we try to scale it up and find a perfect solution for the application. And that's application-driven, based on micromechanics, on really the structural base of our material. And that's very important. Okay, I'm already almost there, 30. So, it's important, if we want to use the rubber, noise reduction, resistance of rutting. Rutting is this famous deformation when big lorries drive over our roads, we have rutting. But we also want skid resistance. For airports, it's very important that you have enough friction. And also surface life is important. Another part, and then that's the environmental benefit, but that's something previous speakers talked about. So it's important that we also take this in account. For instance, with life cycle analysis, we also have a part in our research group, people who are doing life cycle analysis. And it's quite important that you see significant effects when you use reclaimed asphalt, when you use these rejuvenators and all these things. Okay, so I think beneficial. We can play on these mechanical properties, we can make them better, the materials, and we can reduce our waste. We can make it to a better product, and that's something I think which is very important. There is still, of course, some work, and I think the most important work is that we have to understand what these rubbers will do in our asphalt in order to develop nice, really suitable products for the future. Okay, and I thank you.
Zeer bedankt dat u zich ook aan de tijd hebt gehouden en bedankt voor uw late komst. J'espère que l'exemple de Francorchamps n'aura pas jeté un froid dans la chaleur du bitume. Want ik heb dus begrepen dat als de bitume niet wat opgewarmd is, dan kom je inderdaad niet tot die symbiose.
Ja.
Inderdaad, heb ik het goed begrepen? Okay.
So the big problem is if you have a mixing and you don't do it properly, you can lose a lot of your advantages. So it's important to, for instance, if they compact it not well enough, then the properties of your complete structure
will disappear.
They disappear, or they can be completely different. So you can have a perfect bitumen, but a really bad road if you produce it on a bad way.
Dames en heren, Dr. Ingenieur Johan Blom. Thank you very much.